Hello, welcome. Today let's try to solve another Leetcode problem 496, next greater element 1. So we have two arrays, nums1 and nums2. We just want to calculate the next greater element in nums1. So for example, this 4 is in nums1, but it is also in nums2. We want to calculate the next greater element than 4 in nums2, so there's nothing. It's gonna be have a -1. So what about the 1? So for 1, the next greater element is 3, so we have a 3. And for the last one, 2, next greater element is nothing, because here is a 2. We have to use the 2 in nums2, it's not here. And then after 2, there's nothing, so we're gonna have a -1. Yeah, it is not like that. If you have a 2, the next greater element in nums2 is 3, but that is wrong because that is not the description asked. Yeah, we have two nums, nums1 and nums2, and nums1 is a subset of nums2. Yeah, so for each nums1, we need to find an index z. So for example, we have a number 2. We have to find the same number in nums2, and then we're gonna check after 2 if there is a greater number than this 2. If there is, we're gonna append this number inside our result. So if there's no, we're gonna have a -1. Yeah. So this is the brute force. The brute force is O(n) square. Let me just make sure this is right. Yeah. So I'm gonna first loop through the nums in nums1, and then I'm gonna check the index. And then I'm gonna start from the index +1 in nums2 to check if there's a number more than this number n. If there is, so I'm gonna append it inside my result. If there's no, I'm gonna append a -1. Yeah, and this is also a very popular trick for solving the loop problem. We need to have a sign. So this has means false. So here I'm gonna set a has to true. It means I've already append a number inside. Yeah, if this has is still false, it means I didn't find a number greater than this n. So I'm gonna append a -1. Yeah, let me just submit it to make sure this works. Yeah, as you can see, it works, and it is still okay, but this is a O(n) square and time complexity. But let's check what is the follow-up. Could you find a O nums1.less plus nums2.less solution? Yeah, if we were to let the time complexity of n squared to n, normally for this next greater or next smaller element, we can use the monotonic stack. And this is the very basic of monotonic stack. It's like a template problem for us to learn. After that, we're gonna solve a more advanced monotonic stack problem. Now let me make a comment and try to solve it by using monotonic stack. We are going to basically inside the nums2, we are going to find a number. For example, this is 1. Is there a number greater than 1 after 1? So it has a 3. So we're gonna have a hash table like that. We're gonna store the k-value pairs inside the hash table. Now we're gonna check the next number, 3. If there's a number bigger than 3 after 3, there's a 4. So we're gonna store the k-value pairs with 3 and 4. It's like that. Now we are going to check 4. Is there a greater number than 4? There's no. And then we're gonna go to 2. Is there a number greater than 2? No. So this is our hash table. After that, we're just gonna check the nums in nums1, just use the hash table. We're gonna check 4. 4 is not inside, so we're gonna append a -1. And then we're gonna check 1. 1 is inside, so we're gonna append a 3 because 3 is here. And this 3 is the next greater element than 1. And then we're gonna check 2. 2 is not inside the hash table, so we're gonna return a -1. But how should we prepare this hash table? So this is the use of the monotonic stack. Now let me solve it using monotonic stack, and this is basically O(n) time complexity. Yeah, let me put a n on time complexity. But how should we prepare this hash table? Yeah, we can use a monotonic decreasing stack. Why? Because first we have a number of 1 inside our stack. Now, if there's a number greater than 1, we prepare a k-value pairs 1, 2, 3 inside our hash table. At the same time, we need to pop out this number 1, because this number 1 will not be used, and the number 3 will be inside our stack. Next, we're gonna check number 4. So 4 is greater than the top of the stack 3. So we're gonna prepare a k-value pairs 3 and 4, and then we're gonna pop out this 3, because we are going to prepare a monotonic decreasing stack. If it is increasing, we always pop it out. Now we have 4 and 2. It is decreasing and inside our stack. We didn't do anything, and this hash table is the result. After that, we're gonna use this hash table to prepare the final result. Yeah. Now let me prepare the monotonic stack. So I'm gonna prepare a hash table D and stack. So the D will be default dict int, or you can just use the bracket. It's the same. So the stack, I will put the first number of nums2 inside my stack, because for index and the number, it's the same for solving the monotonic stack problem. So I'm gonna use a number. So the first number in nums2 is gonna be nums2 0. So I'm gonna put the first number 1 inside my stack. So this is on top of the stack. It is 1. Now I'm going to use a for loop. So let me prepare a index. So for I in range length of nums2, we are going to loop through the nums2. Now we are going to have a tag. So while there's something inside the stack, basically this is a template. But if you need to understand why we use this, because we are not sure if the stack is empty or not. And for the first loop, from the beginning, this stack is not empty. And we have to check stack -1 on top of stack if this number is less than our current number. So the current number is nums2I. So this means if 1 is less than 3, what are we going to do? We're going to prepare a k-value pair inside our hash table. So the k should be stack -1, and the value should be nums2I. So we just store the 1 as k, 3 as value inside the dictionary. And after that, we're gonna pop it out. So the stack.pop. So this means we popped the 1 outside, but after that, we're gonna append 3 inside. So when we go out of the while loop, we're gonna stack.append our number. So the number is nums2I. So this is the mono stack part. After the monotonic stack, we prepare a dictionary with k-value pairs. It is like this: 1, 3, 3, and 4. Now we just need to prepare the result. So the result would be an empty array, and after that, I'm gonna return the result. Yeah, so I'm going to check all the numbers in nums1. So for n in nums1, I'm gonna check if this n is inside the hash table. If n is in D, so the result dot append dn. If it is not inside, the result append -1. So this is just as the description said. Now let me run it to check if it works. Yeah, as you can see, it works. Now let me submit it to check if it can prove all the testing cases. As you can see that it is much faster than before. It's nearly 80%. Yeah, before, if I remember right, it is 40%. Yeah, and this is an ON time complexity, because while we are using stack, at most there will be an append and pop. It will be O2 times n, and O2 times n is still an ON time complexity. So this is why we gonna use the monotonic stack to solve the next greater element problem. Thank you for watching.